Good day to you people of the internet. So the last time we were together, I was showing you how I put on this full PCB water block on my newly acquired AMD Fury X graphics card. Now if you remember from that video, I was pretty excited about it, and I gotta say, when I got it installed into the rig and benchmarked, I was a little let down. I was only getting about a 12 to 12.5% increase over the AMD 390 graphics card that I had in there previously. It wasn't even the 390X. If I overclocked the Fury from 1050 all the way to 1100 megahertz, I was only getting about a 14% increase in performance. So it was right about that time that a friend of mine had went out and purchased an AMD 590 or AMD 580. And he brought it over to bench, and I was only getting about an 11% performance increase. So the performance between a 390 and a Fury X should be pretty substantial. So I did some researching, and unfortunately it seems like the AMD FX platform just doesn't have what it takes anymore. The fact that it was bottlenecking a single graphics card, not even a Crossfire setup, was pretty eye-opening. So I did some research, and it turns out that the parts that I had been using, which was the Asus ROG Crosshair V motherboard, the FX 9590, and some Corsair Dominator RAM, even being a couple of generations old, still retained quite a bit of value. So I was able to sell the board, the processor, the memory, and my old graphics card for close to $700, which gave me a phenomenal jump into upgrading my rig with the parts you see here. I got an Asus Crosshair VII Hero board, 2 generations newer than the last one I had. This is not the Wi-Fi edition because it doesn't make sense for me in my space, and it saves me a little bit of money. I got the Ryzen 7. This is the second gen, the 2700X. This is a 3.7 gigahertz with 4.3 gigahertz max boost with 20 megabytes cache. This is just a beast of a processor out right now for the money. I got myself some Corsair Dominator Platinum RAM, clocked at 3200 megahertz. Now I know DDR4's default clock is 2133, but from what I've read, with the way the internals of the Ryzen work, utilizing the full speed of your RAM versus back in the day when cast timings were more important, really brings out the performance in the Ryzen. So I'm excited to try that out. I've got an EK Supremacy block here that I had originally had for my AM3 rig, but luckily the Asus ROG gives you both the AM4 and AM3 mounting holes. So this is going to be excellent to cool that chip. And then of course I've got the AMD Fury X along with a couple additional SP120 fans. These are PWM and quiet, so they're nice. They'll give me some good control and low volumes. And I'm going to put these on the top of my radiator here to put my radiator into a push-pull configuration. Now this is a 480 millimeter radiator, and the only things that's going to be cooling is a graphics card and a processor. So that shouldn't be a problem at all. But this XSPC radiator that I have has a pretty dense, thin grid. So putting it into push-pull is just going to help it run a little bit more efficiently. Anyway, so a lot of the videos that you guys may be used to watching are kind of like DIY or how-to videos, where I walk you guys through a process and show you the steps. We're going to be doing this a little bit different. This is going to be more of a vlog of the build process. I might branch off and make a couple of separate videos on things like how I do my cable stitching or how I bend hard tubing for water cooling. But for the most part, this particular build is going to be just like vlog style. So I hope you guys enjoy. When we get to the end, we'll benchmark it and see what we're really able to do, and if we were able to make the Fury, you know, shine a little brighter than it was in the last rig. Anyways, let's stop talking about it, bring all the equipment in the lab, and start building. Okay, here we are in the shop. I've got the case stripped down about as far as I need to. Top panel and the 2 side panels are off. I'm going to go ahead and finish making sure that all the fluid is drained out of my water cooling loop, and then I'll pull the radiator out of the top, get that prepped for push-pull configuration. Then we'll move on to putting the motherboard, processor, and memory into the case itself and start looking at some ways that we're going to route hard tubing. So let's get started. So in my main build, I prefer not to use wire ties. They don't really give the clean, polished look that I'm going for. So for my power supply cabling, fan cabling, I either loom or stitch the wiring with this wax-covered black cotton thread. Now I'll make a video on this specifically, how I do different methods and whatnot, but I just kind of wanted to give you guys a heads up of what I'm going to be doing to these fan cables here. Definitely a lot cleaner look to the wires. Now, when I have a fourth fan on, I'll do the same thing with this side. And the way the fans feed into my chassis, from underneath, there's one hole, and then on top, there's two separate. So this will kind of just click and slide in, and I'll have a really good cooling solution for my rig. Oh, what a beautiful display for a motherboard. That really is a very attractive way to display your board. So it turns out I was wrong. The Asus ROG Crosshair 7 does not also support AM3 mounting brackets. I swear I read in a couple of forums that this board does support it, but maybe I was looking under Crosshair 6 or just misreading something. So unfortunately my EK Supreme water block will not work on this processor. It is kind of sad. So for the time being, or the duration of this part of the video at any rate, we're going to go ahead and stick with the boxed AMD Wraith cooler that does come with the 2700X. I've read some pretty good things about this cooler, that it's got some nice RGB features, that it can decently cool this chip at stock with no tweaking. So again, for the duration of this part of the video, we'll be using air cooling. But that's not really the point, right? You know, this whole system's been designed around this custom water loop, and we really do want to get a block on the CPU eventually. So I've been looking at some blocks, things made by EK and Bits Power and what have you, and it turns out that they make something really cool for the Crosshair line of boards, as well as, you know, other various Intel boards by manufacturers. But it's called a monoblock, and instead of your traditional water block that just sits on top of the CPU and very efficiently cools your CPU, a monoblock replaces the heatsink on your motherboard and also cools the VRMs with the same water block. It's a little bit out of the price range at the moment, so that'll probably be part 2 of this vlog video when I get that block in and we can finish up the cooling system. So the current plan of attack is to use some of my PETG rigid tubing to go from the reservoir to the Fury X, and then I'll just use some soft tubing temporarily to go from the Fury X to the input of the radiator. So let's stop talking about it and get right back to work. Well, we're shy a CPU water block, but that's going to be a pretty attractive setup. That's looking pretty cool. Okay, now that we got the board mounted into the chassis, we can start to figure out some aesthetics. How I'm going to want my cables in, whether I want to adjust the memory in them, if I need to redo the stitching, say to add an extra line of power, but most importantly, how we plan on running our rigid tubing from the reservoir to the input of the graphics card. So as far as the PETG goes, I've got a couple ideas floating through my head. So depending on how I decide to run this, I could be shooting myself in the foot and blocking some of these PCI Express slots. To come straight out of this card with a 90, or use one of these Bits Power elbows and bring the tubing across, and then another kind of 90 in. Now I'll do maybe a more in-depth video in the future on how I do hard tube bending, but in a nutshell, you use a silicone insert that you slide down into the tube and then heat gun until you can get the plastic warm enough to be able to bend. Now the silicone insert helps keep this plastic from caving in on itself. If you say, for example, just took this tubing and hit it, put it over the top of a heat gun and you went to bend it, the hollow here would collapse on itself, but not when you've got the silicone insert. But still, that's a lot of heat in one area. So what we'll have to do is measure this out, achieve this 90, kind of let the plastic cool, and then just focus heat on another section over here and try to get a 90 going back down. It would be convenient if I could just say, add another bracket here, but things being as they are, I don't think that those measurements are going to be possible. So what we'll end up doing is just taking some of these Primo Chill bullet fittings I got here for the hard tubing, and we'll get one right here, and I'm thinking one on the elbow. Now if in the future I do decide to add a second Fury X, Aqua Computer makes a plug that can go on and connect the two cards, or I can just make a small bridge with this piping to add the second one in. But that's for the future. We'll see what happens. With the water cooling loop all connected, I went ahead and reinstalled the PCIe Express power cables. You might notice it looks a little bit cleaner, and I restitched the cable the proper orientation for this card. And if you want to know a little bit more about cable stitching and cable lacing, you can check out the description of this video and I'll have a link to that topic specifically. Anyway, so next on the list is the power and reset button header. This is a 20-pin header that I put together for the Crosshair V board. And the Crosshair VII seems to be a 10-pin header that looks exactly like your standard USB 2.0 header. So I got some empty plugs for USB 2.0, and I'm going to see if I can propagate that plug with all the pins from here. So I'm going to pull out the manual, make sure I know which pins are what, and get to work. Okay guys, we converted from that 20 pin to a 10 pin. basically using a USB 2.0 header that I stole out of a junk computer. Next on the list is the CCFL lighting behind my reservoir system here. I've got two tubes that run around back to an inverter, and the inverter came with this little mess of a PCI bracket and this wiring harness and Molex connectors. I mean, who even uses these anymore? So I plan on replacing it with a little rocker panel, little rocker switch panel that I had made a while back and just never got around to installing. So I'll get it placed in the upper right hand corner of the case, and this gives me a nice, when the door is closed, hidden physical switch to get access to my CCFLs. There's a lot of lighting control options out there now, and I'm sure I can incorporate something into like an Aqua computer setup, but with Corsair links and the ASUS lighting control, that's primarily just for LED lights. So this is just a nice physical switch for those older style CCFLs. Let's get it installed. Here's the finished product. We got our little rocker switch panel connected into a 2-pin plug that'll go into the ballast for the CCFLs, and then a couple of spade connectors to go to the little 12-volt rail that we've got. Let's install it and test it out. Alright, that's going to look a lot better than the wiring harness that came with the CCFLs originally. So let me explain to you a little bit of how I'm powering and running my 12-volt accessories here in the case. I'm using the Corsair AX series power supply, and one of the 12-volt power plug options on the power supply is pretty much a standard PCIe power connector. So I was able to get a couple of those blanks from the internet and make my own little custom sleeved cable coming up to this rail, where then I'm powering my water pump, the fan grid at the top of the case, and soon to be my CCFLs. The nice thing about running 12-volt accessories this way is I can use an external power source, such as this scavenged Linksys wall wart adapter, and I have the female version of the plug that I can just disconnect from the power supply, plug in here, and then by disconnecting or connecting any of the accessories, test them out as a group or independently. So that's what we're going to do right now. I'm going to disconnect everything else from this rail except for the CCFLs, and we're going to test the new wiring harness and make sure it works. Moment of truth. The CCFLs light up. Really the last step we have is filling the loop up with a fluid and making sure that it's not leaking. So leak testing is super important when you're doing a custom loop. And we will go ahead and use our external power source to run the loop overnight, and we'll check for leaks. I cannot stress enough to leak test your rig. It'd be horrible for you to put it all together, spend all this time, jump on it and start playing, and a pinhole leak comes out somewhere and you ruin a graphics card or a motherboard or CPU or whatever. It's just a horrible mistake to make. So take the time and leak test your rigs. I still have some distilled water solution with SysPrep. It's perfect for us to do this leak test. And then when we're official and we know that nothing's leaking, I'll just go ahead and put some distilled water with a Utopia solution in it. And then we can finally benchmark it. All right, let's keep going. Okay. So we want to catch anything that leaks, if it leaks. So I'm going to take some of these nice kind of heavy duty blue shop towels and just lay them around our rig to catch any of the spots there could be water. So areas I would be concerned about would be junction points, would be the areas that we could consider, leak hazards. Okay, so I've got the pump and the CCFL hooked up, and we'll have that so we can get just a little bit of light. You don't ever want your pump to be dry, so make sure to watch your levels. Now right here, I've got a little Bits Power pressure relief valve. So what I can do is when I want to make sure there's no, or the pressure equalizes while I'm filling, I can press this in and it'll bring any of the remaining fluid in. Okay, so we're gonna let this run overnight and make sure that we don't have any leaks, and we'll see you guys again tomorrow. Excellent, 0 leaks. This has been running for just about 24 hours now, and I think we can successfully say that this is a good non-leaking sealed loop. We are so tantalizingly close to being able to turn this thing on. I think really all that's left is just going to be to button up the case and benchmark. Maiden voyage. Let's see if it posts. And it posts. Alright, let's get into the UEFI and make sure everything detects correctly. Alright, it detects the 2700X at 3700 megahertz, all 16 gigs of RAM at the default DDR4 speed. Great. Alright guys, well I'm going to finish this up here in the shop, and I'll be back to you in just a little bit with some benchmarking. Okay guys, so I'm a little guilty and I got to admit it. I finished putting the rig together, brought it here in the office, and well, got captivated by some games and got sucked in for 6 months. But my monoblock just arrived, so I figured I might as well finish this video before starting the next one. So let's dive into those benchmarks. First up, we're going to look at some GPU benchmarks using 3D Mark's tests Firestrike and TimeSpy. When I first switched over from the 390 to the Fury X, I was expecting a big boost in performance, as the Fury X was the enthusiast level card at the time. However, I was only seeing like a 12 to 12.5% performance increase over the 390. So I did some research, and obviously the 9590 was bottlenecking my GPU. So pairing that same Fury X with a 2700X set bone stock, I'm getting a 45% performance increase on the same graphics card. That's excellent. Now if I go into BIOS and use the memory profile and set the DDR4 speeds to 3200 megahertz, that performance reaches just a little over 47%. The general consensus online is there's not a ton of room for overclocking on the Fury X. However, you can still make some modest gains. So if I take it from 1050 to 1070, I can get the best score I've gotten on Firestrike so far of 15,303. Curiously though, if I push it a little farther to 1080 or 1100 megahertz, I get a performance decrease. So I reran TimeSpy, but this time with a GPU monitor open. And we took full advantage of the clock speed no matter what I set it to, so it's not like there was some R9 throttling going on. And we were only using about 1.6 gigabytes of the VRAM. So I don't know if the performance decrease is some bottleneck within the card or just a result of Firestrike being a little bit older of a test. So let's take a look at TimeSpy. On this benchmark, we see much of the same, a substantial performance increase over the 9590, 21% to be exact. And if we increase the memory speed from 2133 to 3200, we get about 22% increase. Unlike Firestrike, however, if we apply our modest overclockings going from 1050 all the way up to 1100 megahertz, we see some performance increase with every uptick of the clock. TimeSpy is based off of DirectX 12, so perhaps it's taking advantage of the 8 cores, 16 threads of the CPU, or perhaps the high bandwidth of the HBM memory. Both of these tests, however, are pretty synthetic, so I'm going to do a Rise of the Tomb Raider bench and see how it works on a real game. In this chart, we're looking at the difference between a single screen 1080 resolution and a 3-screen Eyefinity setup at 1080. At the default clock speed of 1050, we're getting 87 frames per second on a single screen and 40 frames per second on an Eyefinity setup. Overclocking to 1070 or 1080, we do see a performance increase on the single screen, but a performance decrease on the Eyefinity setup. It's not until we overclock all the way to 1100 megahertz that we're seeing positive numbers on both the single and triple screens. All of these benchmarks were done using the most current 2019 Radeon driver. I believe it's the 1850 revision. So we can rule out any optimization as a source of performance increase or decrease. So I guess the real takeaway at this point is there's no one-size-fits-all solution for overclocking your GPU. There's a lot of factors to keep in mind, such as API, software optimization, and the speed of the memory on your card. So to get the most performance out of a particular piece of software, you should probably benchmark it at a few different speeds and see what gets you the best results. Moving over to a purely CPU-based benchmark, let's take a look at Cinebench's R15. The performance improvements on the 2700X over the 9590 are absolutely staggering. At default DDR4 clock speeds, we're getting 140% performance increase. Set those memory timings to 3200 megahertz, and we're getting 147% more performance than the previous FX platform. So, the results are in. The legendary 8-core 5 GHz FX 9590 was indeed bottlenecking my Fury X, and jumping from the FX platform to the Ryzen 2700X has had an enormous impact to my gaming. This has been a really fun build. I'm glad that you guys came along for the ride, and I'm excited to put the monoblock in next. Back to the graphics performance though, however, you guys did take a look at the performance results of the Rise of the Tomb Raider, and playing a game like that on maximum settings across Eyefinity is pretty taxing, and my frame rates were dropping into the very low 40s. Now the FreeSync capability on these panels is from about 40 Hz to 144 Hz. So anytime I drop below that for any reason, that's when you start introducing some tear to your screens. So who knows what the future is going to hold. Anyways, thank you very much for watching. If you liked this video, consider hitting that like button or subscribe. And till the next one.